Good morning, everybody. My name's Kate Bourcherel. Welcome to IoT Oracles from Delphi to Diamonds, which is part of BrightTALK's Web Summit on the Internet of Things that's taking place this week. I'm really glad you could join me today. Let's go on and start off with some introductions. So a little bit about me. I'm a digital strategist. That effectively means that I look at the strategic impact of technology within a business. I have an accounting background, so business processes are absolutely my thing. And I've become very fascinated with emerging technology and the application of blockchain and distributed ledger technology, as well as obviously Internet of Things, artificial intelligence, machine learning, and so on, all of the things that are coming through that can make our lives easier and impact upon businesses and enterprises and lives throughout the world. I'd be really interested to know a little bit about yourselves. So if you could tell me something around your experience of blockchain, that would be kind of useful. Are you developing blockchain applications, or are you not sure what a blockchain is at all? Are you looking at cryptocurrency rather than business applications? Were you aware that that blockchain has applications way beyond cash? It would be really good to understand where exactly you are. So I am working with CityWeb Consultants. We are applying blockchain, artificial reality, virtual reality, and machine learning and AI to wicked business problems alongside standard business development. We've been working in software for the last 8 years now. I co-founded emerging technology group Sphere Network here in the northeast of England, and I've been around businesses since way back when the AS400 was a really cool piece of software. The World Wide Web didn't exist, and I was an intern in an IBM business partner in Denver back in the day. Let's have a look at what we're going to cover today. I want to do effectively a blockchain 101 just to make sure that anybody whose understanding is very at the introductory level can follow everything that we're doing. And I can see from the responses to the poll that actually this is going to be useful for the majority of the audience. We'll then move on and have a look at how Internet of Things and blockchain really converge nicely to produce a very strong business case. And have a look at who's doing this, who's actually using blockchain and Internet of Things, and is it something that you should be looking at in your own business, in your own life. So let's start off with how Bitcoin became big business. I mean, way back in 2009 when the Bitcoin blockchain was first posited, we had cryptocurrency was turning up in sci-fi novels from Asimov to Douglas Adams. I mean, how else do you think people would buy cocktails in spaceports and hire floating scooters to get around interplanetary cities? But nobody had solved the problem of double spending, the duplication of digital assets. If I hand somebody a $5 bill, then I can't spend it again. It's left me. With a digital asset, how can you actually prove that this asset has moved from one person to another? And it's actually Bitcoin that was the first working solution to the problem of double spending. And the way that it works is it literally is a chain of blocks. So here is a chain. Here is a representation of what is genuinely going on within the Bitcoin blockchain. This is actually information from a block that was stamped on the 31st of May 2018 at 14:07:08 British Summer Time. So in this block we have the timestamp, so we know irrefutably when a transaction took place. We have a single cryptographic hash of all the transactions that were recorded in that block. There were 658 of them. You can actually check it on the URL. And we have a reference to the previous block. So this is important because that is the start of the chain. We then have a reference to the next block, and we have a validation result as well. So we have a block of information saying these things happened at this time, and that references where it is in the chain. And what it means is that block number 525287, which is what this is, has a reference in it to 525286, which means you can't go back and change 525286 because it changes the content of the current block. So that means that the information in a blockchain can't actually be changed. Now, how does this become interesting for us? Well, it tells us that, first of all, everyone has a copy of the data. I can go into that blockchain explorer that I just put up on the screen, and I can see everything that's happened in the chain. So we call it a distributed ledger. That ledger is distributed around everyone, in that case, who is using Bitcoin blockchain as a special user. I don't see that when I'm a node, but you can see it on Chrome. You can just go into the browser and find the information. What else does it tell us? It tells us that everyone agrees on the data. This is where the validation code comes from in that block. So we have a position where the community that is running the blockchain have to agree on the data. You're not relying on a centralized agency to say this is correct or this is not. So you have less possibility for fraud. What do we have next? We have immutability. No one can change the data. Immutability is one of the big words of blockchain, and you'll hear that a lot. No one can change the data. Everyone can see it, and everyone agrees that it is right. We have transparency, so anyone can check what's happened with that data. So that's going back through and seeing the information. We have another big blockchain word, I'm afraid, disintermediation. That means you don't have to establish trust. Because everyone agrees on the data, you don't have to say, I trust this person in the center to manage my data and to be clear that all the transactions are correct. It's like you don't have to trust your central bank to process payments because everything is being done in this blockchain, in a peer-to-peer mechanism where the validation of the transaction is done by consensus. Do ask questions if this isn't clear, because it is quite a complex concept, and there are so many ways to try and explain it that sometimes I don't get the right one for the people that are listening. So please ask questions if you want this to be clarified. So everyone has a copy of the data, everyone agrees on it, anyone can check it, no one can change it, and there's no central authority. It's decentralized. We don't have to trust a central group. And the interesting thing for the Internet of Things is that we have business rules encoded in the blockchain. These are what's called smart contracts. Okay. Before I move on to explain smart contracts, there is a question here, Bitcoin as a global currency. I will jump in and digress on that. Bitcoin itself is a global currency, just to answer this question. It is a currency, but it's more like the exchange of gold. So you could pay for something with gold. Its value goes up and down, but it is a reserve of value because it has a particular natural scarcity. Bitcoin is actually a currency with a natural scarcity, and it will eventually settle down to be a reserve of value like gold is. In terms of scalability, this is to do with the number of transactions that can be processed by a blockchain. There are certainly fewer transactions being processed by blockchain than there are, for instance, by Visa in any given minute. However, blockchain is still a new technology. It is less than 10 years old, and people are working on scaling all the time. So cryptocurrency, yes, does have a future as a global currency. Bitcoin itself is likely to be a reserve, and for anyone who's concerned that the mining of Bitcoin is destroying the planet, the huge amount of work that is going into environmentally friendly mining, the use of renewable energy, alternatives to consensus mechanisms that involve lots of computing power, this is a technology for the future and a currency for the future. I hope that has answered the audience question, which was, blockchain as a technology is great, but Bitcoin as a global currency, has it really got a future due to scalability and energy consumption? So, returning to blockchains themselves, we know that everyone has a copy, everyone agrees what's in that blockchain. You can't change it, you can check it, and there's no central authority that you need to trust in order to transact. But the clever thing are these smart contracts. So just to explain what a smart contract actually is, this is the interesting thing for Internet of Things. It's the software that defines the language of transactions. It's absolutely nothing to do with a legal contract. It is purely the rules that govern business. So in a very simple way, the Bitcoin blockchain says somebody is transferring an asset, a coin, from here to here in the ledger. Does it already exist in this place? And is it being sent to a place that exists? And if the answer is yes, then the transaction is completed. A classic one that I would love to have a blockchain running my children playing chess at home, because they cheat. So if I have a child trying to move their pawn 6 spaces across the board and 3 to the left to take the queen, that's not going to pass the smart contract. The smart contract very clearly says that that pawn can move 1 space forwards, or 2 spaces on its first go, or 1 space diagonally to take a piece. It can't move 6 spaces across the board and take the queen. Try telling that to 2 children who are fighting over a chessboard. If they had a smart contract that would not allow them to move on to the next part of the game without moving correctly, it would make my life so much more peaceful. But joking aside, encoding business rules becomes really, really important when you step outside cryptocurrency and you move into business problems. So this is where smart contracts become a bit of a game changer for us. They're not the first software to encode business rules. I mean, I use accounting software that will post double entry to different ledgers. That's absolutely fine. I mean, there are plenty of things, but these are particularly interesting because they allow multiple stakeholders to be participating in a blockchain of transactions without having to do a huge amount of intervention. You don't have somebody deciding all the time what happens. You can encode the rules so that you trust the process and not the individuals. We call it trustless processing. The interesting thing here is that the transactions could be based on direct input from things. A really straightforward example is I'm sitting in a supermarket and I am waiting to accept a delivery. I want to be sure that that delivery of cold meat has been kept at the correct temperature So there's going to be no risk of E. coli infection for my customers. Now, I could trust the driver who says, it's all right, I've checked, and the thermometer says that it was always held under the specified temperature. Wouldn't it be much better if that thermometer was connected to the Internet of Things and I could see whether there had been temperature fluctuations in the truck, and without even having to check it myself, if the temperature has risen above an acceptable level, then the shipment can be automatically rejected or, conversely, automatically accepted without having to ask an individual to intermediate, and allowing people further up the chain to trust that what they're buying has been correctly managed all the way through the supply chain. So that is part of supply chain management, but let's look at other ways that you could use Internet of Things to put information into a blockchain. So supply chain management, you have the thermometer telling you that the cool chain has been maintained. You have sensors and RFID that could allow you to track the passage of items as they move from the producer to the processor to the wholesaler to the retailer. You could in the future see things going through customs, track things as they travel around the world. The potential for supply chain management using blockchain is in any case very, very strong. Mixing in the Internet of Things and mixing in the sensors, then you start to get some very strong information that is going to reinforce the integrity of the data that is being held. Asset provenance is another one. I want to be sure that an asset is has passed through the correct channels. I want to be sure that something is not counterfeit. If there is a way of embedding an Internet of Things sensor or identification, for instance, threads with RFID technology, could that show that an item is what it says it is? Energy production and consumption is something where, again, the sensors and the network of the Internet of Things, combined with blockchain technology, allow a very strong, decentralized, independent network to develop. In insurance and fintech and the banking sector, there are times when you want to know where something is. You want to know what condition it's in. You want to be able to track things absolutely. I'll run over some case studies around these in a moment. Digital identity is an interesting one as well for sensors and for just for people. I mean, we start with retina scans and we work from there. But the option to use some sort of sensor in identity combined with banking gives extreme strength to the blockchain. The important thing here is the oracle. Sorry for the picture; it was the only one I could find. So we talked about Delphi in the title of this webinar. So the idea of the oracle at Delphi has gone into the blockchain language. And whenever somebody puts something into the blockchain, then they are known as the oracle. So if I enter some information, I am the oracle. I'm very pleased with that. But what we want to be sure is that we're not back to the age-old problem that I remember learning in computer science back in the 80s, which is garbage in, garbage out. Smart contracts are only going to be effective if the inputs are correct. So the Internet of Things strengthens our blockchain applications and the information that we're able to gather from the data that's held within the blockchain, because we are minimizing the amount of garbage that is going into those ledgers. So a thing, excuse me. So a thing a thing that is connected in the ecosystem of IoT is our oracle. It is the thing that is putting information into the blockchain, and that is where the huge power of this convergence between Internet of Things and blockchain really comes into play. Is everyone following okay here? Are there things that you would like me to go back and explain? I don't see any current questions that I haven't responded to. So please do drop a question on if there's anything that's unclear at this stage. So let's have a look at why, in detail, the Internet of Things and blockchain become so significant together. The first thing is trust and security. So the encryption within blockchain and the distributed storage of data, so that everyone has a copy of the data, these add a new layer of data protection around things that are held in our networks. We saw way back in one of the earliest slides that within the chain itself, all that is held is a cryptographic hash of all the transactions that are in that chain. So this isn't a database. All the blocks in the Bitcoin blockchain, for instance, are very tiny. They're all less than a couple of megabytes. So there isn't a huge amount of data being held. So we have encryption. We have these cryptographic hashes that are being used. The data is being stored in multiple locations. So if one data location is hacked, for instance, or goes offline for any reason, then you haven't lost the data. So there is security in terms of redundancy, and there is security in terms of there are multiple attack vectors. There is no single place where somebody could attack the blockchain. The Bitcoin blockchain really is a good example of this. For 9 years that blockchain has been operating, there is a huge amount of value in that chain, and it must be a daily target for hackers, but it has not, touch wood, been compromised because of its distributed nature, because it's very hard to take something down that is out there like a spider's web. Okay, so we're talking about encryption and the question of what happens when quantum computing comes. So this is a very common thing that you hear, that blockchain is fair enough. It relies very heavily upon cryptography for its security, but quantum computing is in its infancy, is solving very complex problems. Now then, the current cryptography could be broken by a quantum computer that is dedicated to do this. The people who are championing quantum computing, I'm thinking particularly of Whirly, for instance. If you look up at Whirly, that's W-H-U-R-L-E-Y. I'll just drop that on here, actually. At Whirly, you should be able to see this, is the man to see for quantum computing. There we go. So this is the guy that you need to follow to understand about quantum computing. He is absolutely championing it. He did a very good talk at South by Southwest on quantum computing. They're not computers that you would sit on your desk. A quantum computer looks like something out of steampunk at the moment because it has to operate at is it plus 0.5 Kelvin? It's a ridiculously low temperature. The chances of having a quantum computer that is dedicated, first of all, to breaking cryptographic hashes is low currently. And in addition, as the quantum computing increases, so the cryptographic hashes can increase. At the moment, you might work on 256-bit encryption. We simply increase the number of bits encryption that we use. So there are certainly, quantum computing is going to has the capacity to break existing encryption. However, we don't believe that it is a genuine threat to blockchain technology in the long term. I hope that answers the question, but please do read up on it. So, still confident that encryption is giving us security. Let's move on to other areas where the Internet of Things supports the blockchain. We have the recording of transaction details with no human oversight. So this goes back to the thermometer, the thermostat in the truck. But really, in any situation where you have reliance upon machines, then you have the details coming through without that human intervention, without that human error. Obviously the Internet of Things really starts at the moment with pulling information from machines. I know there are some splendid businesses. I was talking to a guy from AdLink recently, and they are working on bringing information from analog machines into the Internet of Things because they add value to business. So we are automatically extracting value from machines, from the data that is being generated, and that is reliable data. That is not something that can be interpreted before it goes into the blockchain. The immutability of records again means that there is no chance of tampering. The way that blockchains are established is that there is a point at which they cannot be defrauded. There is the incentive to maintain the blockchain is much greater than the incentive to collude, and the way that the that validation and consensus and agreement is reached is carefully structured to ensure that nobody can be what they call a bad actor, that there are no bad actors that can actually influence the content. And you have that trust element. Even if you don't know the other people in the blockchain, you can trust the data. You don't have to trust the people involved. And that gives you some scale beyond a normal network. It allows you to scale beyond your village. It allows you to scale out to the world. The next advantage will sort of group into transparency and efficiency. So activity can be tracked as assets move through the distributed ledger or around the world. So you can actually see what's going on with your assets. There are already some good case studies with reduced costs of administration and savings from fraud prevention, which may balance the investment in implementation. Outside of the Internet of Things application, there is a particularly good blockchain example that I'm aware of. I'm not sure if it's in the public domain, so I'm not going to say who it is, where people are transferring money from one state to another for humanitarian purposes, have been losing around about 10% of the value in the cross-border transfer. And by implementing a blockchain solution for this cross-border, they have reduced that loss to an estimated 1%. So that reduced cost of administration has balanced the investment in implementation. There is actually a very good case study that I will cover in a moment, where there is, again, administration costs and fraud costs have been considerable as a result of implementing a simple blockchain solution. So we have the potential to actually save money, which is always a great driver for business. So let's have a look at who's actually using blockchain and the Internet of Things, and whether you should use it as well. So we're going to look at 3 different types of use of blockchain and IoT technology. So the first one is the diamonds of the title. Provenance and Compliance. There is a great business called Everledger, which was set up in order to follow the identification of initially diamonds, but now spreading out to luxury goods. There is a link at the end of this presentation to their website. So Everledger have established a mixture of blockchains, one which is transparent to the public, and the other which is private, so that only people who are commercially involved in the diamond trade can see certain commercial elements of transactions that have gone on. That's kind of useful for commercial confidentiality. I haven't mentioned this before, but there are public and private blockchains, and the private blockchains enable a certain element of commercial confidentiality, which is vital. We also have an interesting one that I came across called Modum, and they are using sensors to track the environmental conditions of pharmaceutical shipments. So this goes back to the thermostat and the E. coli and the ham, that they are using a standard element of the Internet of Things in order to show further up the supply chain that you have compliance with regulation during the shipment of pharmaceuticals. So we are combining here blockchain and IoT for the provenance of assets and to ensure compliance with regulation. Moving on to another example, straight into the supply chain and food safety. So a lot of this work has been done by IBM, IBM Watson, obviously huge resource for data processing, machine learning, and Hyperledger Fabric. Hyperledger Fabric is a specific framework for private blockchain, for a private distributed ledger around members of a supply chain. It is part of the wider Hyperledger project, which is being run by the Linux Foundation, and they are particularly specializing in blockchains that are useful commercially, hence the privacy. So IBM Watson and Hyperledger Fabric is specifically looking at Internet of Things data being added to a private blockchain. So there are plenty of proof of concept supply chains in existence. So Walmart, for instance, famously tracked the full shipping history of 2 mangoes in the space of 2 seconds using IBM Watson and Hyperledger Fabric. I believe that there is a link to that at the end of this presentation if you want to read up a little bit more. But there are plenty of say, proof of concept going on in this area. A classic example which is used by the Hyperledger Foundation, the Hyperledger project, to demonstrate how blockchains might work is a hypothetical supply chain for tuna. The ultimate goal would be for a tuna fisherman to be identified as a regulated fisherman when they upload information about their catch, for the catch to be identified as coming from a regulated fishing area by its GPS, for the transfer of these batches of tuna to be regulated through the cold chain using Internet of Things enabled thermostats, to see that processing is carried out according to regulation, and that information could have come from Internet of Things enabled machinery within a processing plant, and so on. So every stage of transfer from sea to plate could be reported upon by a machine in the network of Internet of Things, a sensor in the ecosystem, and can be seen by the people who are involved in that supply chain, from fisheries through to consumers and from regulators through to compliance. Moving on, we look at insurance and fintech. So there is currently, there was a proof of concept run by Moersk, the shipping company, as they have rolled out blockchain for insurance purposes with their insurers XL Caitlin. Now, what they've done here is to track the hulls that are insured around the world, so that quite simply their insurance is up to date, because these hulls can be bought and sold. They can transfer from one owner to another, and so Moersk's insurers have moved from an annual report of where things are to a real-time report of where things are, so who owns them, so that the insurance costs are up to date. So the savings on having real-time insurance premiums based on ownership proved so successful that is now being rolled out as a real application. So that has gone from proof of concept to actual implementation, and is within a few weeks of actually being rolled out in full. Another one is a nice little application that I came across in March. Payment devices with instant settlement. The slogan of Festi, who are trialling this, is leave your wallet at home, and it's aimed basically at people at festivals, at music festivals. So using IoT devices, a wristband to pay with, and not relying on the connection to your phone or to your bank in order to make payments. It is a particularly interesting application, a simple application of IoT and banking. Another one that is being looked at, it's something that at CityWeb we're examining, is the automatic release of escrow balances. So if you're buying a house, for instance, we currently transfer, our mortgage companies transfer money to our solicitors. The solicitors release the money from escrow when contracts are exchanged, so completion can take place. So how could that be done for the transfer of physical assets? A great example would be cross-border transfers. So if you are exporting, can you show that something has passed has crossed the border, or has been received at a particular place, so that the balance of payment can be released? That's a really significant area of development for businesses who are strangled by the vagaries of export finance, and something that could become very, very interesting in the future. The last example that I have here is a particularly interesting one, which is the Internet of Energy Things. So in the UK, the Internet of Things Research Hub PETRAS is working on peer-to-peer energy trading and demand-side management through blockchains. And this is being mirrored by a little trial in Brooklyn called TransActive Grid. And the peer-to-peer energy is effectively, on one side of the street there are a number of houses who are generating electricity, generating energy from solar panels, and they can sell direct to their neighbours on the other side of the street without having to go through the centralised agency. Now, I see this. I have solar panels on my house, and when I put my readings in, I have an assumed export to the grid. Wouldn't it be nice if you could say this energy was generated at Kate's house, and somebody has bought it, and so you can actually have real-time peer-to-peer exchange of energy using Internet of Things and blockchain to manage that. So these are some good examples of the kind of work that is going on in that convergence of IoT and blockchain. There's another question come up here. So we're talking about competitors to blockchain technology. The question is, there are next generation distributed ledgers. So is it moving so fast that implementation will lock people in to the technology? We're quoting here, for instance, IOTA, which is a blockchain for machine-to-machine payments, in inverted commas, and Hashgraph, which is quite interesting. So blockchain technology is moving very fast. Strictly speaking, it's distributed ledger technology, because a blockchain is a simple linear one. A blockchain is a distributed ledger, but it's like a Hoover. We're starting to call them all blockchains. People are aware of this, of future compatibility. There have been questions raised with, people at, for instance, the Hyperledger project, around how will the private blockchains manage as they scale beyond a population that can strictly be thought of as private, for instance. I think that the different technologies are aware of the speed of development. There is always going to be some element of lock-in in any technology. I mean, look at Windows and Mac, but it is not something that we're unaware of. I don't think I can come up with a better answer for that question. There's a huge amount of development at the basic level. No, it's not that you're buying in. It's not that you're buying in a framework all the time and then building a blockchain, building your distributed ledger system on top of it. There is, we're in such early days that everything's being developed from scratch pretty much, and it's a lot of open source technology. I think, actually, yeah, I'm trying to answer the question sensibly. So blockchain technology is moving fast. There is a risk of lock-in. However, unlike Microsoft, Windows, Apple, Mac operating systems, these are not all private companies. So Hyperledger project, Ethereum, and so on are all open source, which is the big difference, I think, between the old and the new. I believe that the software development community is wise enough now, after all the proprietary lock-ins, to work together on open source to develop those frameworks so that we minimize lock-ins in the future. So I wouldn't be afraid of dipping your toe into blockchain technology in fear of being locked in. I think that we should be jumping into blockchain technology and contributing to its longevity. I hope that answers the question, and I trust that it makes sense to those who are listening. So that is the final question, actually. So how would you get started on putting in a blockchain? A few little checklists for you. Do you have a real business problem to solve? Blockchain is a bit of a buzzword. We need a blockchain. There's a great Dilbert cartoon where one of the characters says, we need a blockchain, to which Dilbert thinks and says, what color would you like it? And he's told, well, purple. I've heard purple's good. So it's not something that you must have. It's something that you would have if you needed it. If you don't have a real business problem, or if you have a business problem you could fix without a blockchain, you don't need a blockchain. Interestingly, some people that come to us who say, I need a blockchain, when we start looking at the data flows and the business processes, they might need a very small blockchain, they might need no blockchain at all, or it might be something that is absolutely a bang-on 100% use case. So understand your own business processes before you make the leap into blockchain technology. Bear in mind, blockchain, it's not something that you would implement in a very small community. If you can do it with everybody accessing the same database and you know and trust everybody, that's absolutely fine. Do it that way. However, if you have multiple stakeholders, if it's very clear that you couldn't have fixed the problem before and the benefits justify the cost of adoption, then this is definitely where you need to be. So I'd be interested to know where you'll go from here. So there is another poll appearing here. So where are you in terms of your blockchain? Are you already developing blockchain? I think there was a couple of people who've already said that they are. Can you see a use case in your business? Do you think you can see a use case in your business? Can you see that there definitely isn't, which is an equally valuable takeout? And would you like to learn more? So I'd be interested in knowing where you're going to go from here. I'd also be really interested to hear from anybody who would like to discuss the adoption of a blockchain. If there are any further questions, unless there are any further questions, then I'm going to move on and close the webinar. Be interested to see any of your votes. Right. Okay, I'll leave the poll open. It would be great if you could connect with us. Find me on Twitter at Kate Borcherel and at CityWeb Consults, or please visit the website, drop us a line. And thank you so much for attending. It's been a real pleasure. Goodbye.